Hello everybody, this is Tezlon. Welcome aboard the Train of Thought, where we look at various concepts and transport fever and kick the bull off the tracks. You will have nothing to beef about because we will not steer you wrong. Hello everybody, welcome to the Great Engine Configuration Test here at Train of Thought. We've seen discussions over a period of time now that are very interesting, and that is people in middle and later stages of the game, when they get to big, long trains, long tracks, they debate whether having one long train with two engines is better than having two shorter trains with single engines. Which one is most effective at moving product down the line and generating the most money along the way? And I haven't seen anybody test it. Ever since I've played the game, I've seen people talk about it. Never seen anybody put forth a test to actually see which one is better. So I started being intrigued by this idea. And then I started thinking, the reason, I personally just add another engine. The reason we have to add that second engine is because our single engine isn't powerful enough to pull the loads we're putting on it and negotiating the terrain we're forcing it to run over. Well, how is that any different from our starter train? Because whether it's Europe or USA, back in 1850, neither engine is powerful. In fact, they're both weak. They can't handle a lot of cargo. They definitely can't handle any kind of terrain change. It slows them down too much. Maybe it would be a good idea if we started on our first lines using double engines or using two shorter trains with single engines. And now I'm really intrigued because maybe I just figured out a way to make my first starter line, and this is in hard mode, more efficient. Maybe if I can generate even just a little bit of money more rapidly, that really explodes over the course of my whole game into gobs and gobs and gobs of more money down the line. The more money I can make early on, the greater I can grow that into as I go. It's like investing money in real life. You get more seed money, you end up with more output if you invest it the same way, significantly more. And so we came up with a test to figure this out. Let's run some simulations and get some data and see which engine configuration is the best. And maybe it'll change from scenario to scenario, situation to situation. And so we're going to have different phases to the test. We're going to have phase 1 and phase 2. Maybe a phase 3 at the end of it all if I feel like doing it. In phase 1, we're going to look at an initial layout, building our first track. And we're going to look at a couple different scenarios. Number one, if you notice right away, this track has terrain change on it. About 25 to 28 meters of terrain change. Not ideal for a starter track, but maybe if you're starting it on a mountainous map, this is something you're willing to deal with because it's the best route available. So you're willing to take a little terrain change. And we'll do a series of tests on this line, and then we'll go to another test track. We'll go to another test track and we'll do the same series of tests on a line that's as flat as we can make it. Won't cross over any contour lines. We'll make it as smooth as we can, and that will more closely simulate what most people try to do as a startup line. And that will be phase 1. Now, the different trains we're going to look at along the way is we'll do it in 2 different series. Each setup we'll test 2 different types of, we'll test 3 different engine setups with 2 different cargo setups. So the very first set of simulations will be 6 cargo cars. And we'll first test a single Baldwin 6 wheels with 6 cargo cars. Then we'll repeat the test with 2 engines. And then we'll cut the train in half and run twin trains of 3 cargo cars and single engines. And we'll do that both on the terrain change and on the flat map. And then we'll come back and say, just in case, running double engines, maybe it can handle more cargo capacity. And we'll do the same thing again with 8 cars. So we'll run a single engine 8 cars, double engine 8 cars, and then twin engines of 4 cars apiece, both terrain change and flat. And that'll give us a really good idea of which engine configuration works best to start the game off. And the way we're going to do this is, because you don't want to sit here and watch a train mindlessly go back and forth for 20 years at a time, multiple iterations in a row, we will have the video on when we start a run. You will see us build the train. Everything else will already be built. As a matter of fact, it already is right now. This is the save map we're going to start from. Everything is already in place except the train. You'll see us build the train, and then we'll document what loans we have at that point. And then we'll put the train in motion, turn off the video, and when we get to December 1868, we'll turn the video back, invite you back into the test, and you can watch for the last 2 years as the train, because we're going to go to the end of 1870. You'll get to watch the train run back and forth a couple loops, just so you can see how the different configurations work at getting up to speed as they go up the hill, getting up to full speed when it's flat, and in the flat terrain you'll see how the different engine configurations work efficiency wise and speed wise. And then January 1st of 1871, hit the pause button, record how many loans are left. We'll take that amount, because I doubt anybody's going to manage to pay off all the loans. It's just too much to pay off. We'll take whatever loans are left, subtract the amount of cash in the bank, and that will give us the final figure. Whoever has managed to reduce the loan amount the most has put us in the best position to grow our track farther down the line, and they will be declared the winner. Now, the train configuration that wins on terrain change may not be the same that wins on flat terrain, and maybe 6-car trains can win flat terrain, but 8-car trains can win on elevation change. I don't know. We haven't run any of these out, have no idea what the final numbers are going to be. We have run the simulations just a little bit, and here's why. We want to get the truck route in tune with our ability to bring cargo back to the freight terminal. And so in each simulation, before we show you the entire run, or the portions, the beginning and the end of it, what we've done is gone in and run the simulation just long enough that the train starts running at full capacity both ways. And then we let it make 2 or 3 loops, whatever was needed, to fine-tune the number of trucks we need, so that we don't end up with excess trucks running empty because we have too many, and we also don't create a storage surplus that will degrade the efficiency of our trains running on the route, because if we get too much storage, then production slows down and we don't get an honest look at what we're trying to find out. So there's going to be 2 in this phase 1. There'll be 2 variables in play besides the engine configuration itself. The number of trucks will vary between the single train and the 2 double trains. Both versions of double engines require the same amount of trucks. And because they're bringing cargo back a little bit faster, they need a couple more trucks. Depending on whether there's 6 cars or 8 cars, they need either 1 or 2 more trucks than the single engine does. So that is a variable that exists, that really exists, so that we make the train's efficiency, we keep it at max efficiency. And then the other obvious variable is going to be when we run the twin trains, we will add double track to this line, so the trains don't have to sit there and wait to get to a side branch and go around each other. We want them to be able to run unimpeded to get a true look at how much money they can generate. And the way we'll bring the twin trains out onto the line is we'll build both the trains, look at our loan amount, and then we will send one train out. And when it gets down to about right in here, we'll send the other train out of the depot onto the line. And so they will get to run the entire simulation at opposite ends of the loop, and they should never interfere with each other, so that we can get an honest look at how much money they're able to generate on a starter track. Because on a starter track, you don't have to worry about a whole bunch of trains. That's one of the issues people talk about later on in the game. Well, there's other trains on this line, and if I run 2 engines on 2 different trains instead of 1, am I going to cause more cases where trains have to stop because we have 2 trains trying to operate on the same block of rail? That's not a problem when we're first starting out. And so, like I said, at the end, we're just going to look at the loan amount, bank amount, subtract. Whoever ends up at the end of 20 years with the least amount of loans left over is the winner. And then in phase 2, there aren't initial startup loans. All the tracks we assume will be double tracked already. So we'll have the exact same system. It's going to be longer than this because we have faster trains. We'll make it about the same line time overall. And we'll do 14 cargo train, 14 cargo cars, a single engine with 14 cars, a double engine with 14 cars, and then twin single engine 7 cars. So the cargo is going to be exactly the same for all the simulations, and we'll do one on terrain changes, do one on fairly flat land, as flat as we can make it, given the route's probably going to be twice as long as this one. It may not be possible to get a completely flat route, but it'll be nearly flat. And so at the end of it all, we'll be able to look both in terms of starting a train out, starting the company out, and later on in the game where we have something already in place, which engine configuration is best for which scenario. And like I said, I think I said this, maybe I didn't. When we get to the longer train, phase 2, we'll just look at how much money is here at the beginning, subtract that from how much money is there at the end, and that's a quick and easy way to see how much money the train generated during the test period. Because there it'll be, I don't know what time period we're going to look at, but obviously we have to have the trains up and running in order to have that track set up. And so we will have don't know how much money is going to be over here. We'll just have to wait and see. But either way, we'll subtract it out from whatever they have at the end, and that'll give us a precise figure as to how much money that train generated over those 20 years. We'll still do it for 20 years. I just don't know what my starting period will be. When we set up the test track, we'll find out. So, hopefully this is interesting to you, and you'll climb aboard the train of thought as we conduct the Great Engine Configuration Test, Phase 1, coming up.